Hi, I'm Rich with Inside HPC. We're here at ISC 12 in Hamburg, Germany. I'm here with Geoffrey Noer from Panasas. Jeff, what is Panasas showing off here today at ISC 12?
Well, so as you know, Panasas is all about parallel storage, and we've been working on the various challenges of big data for many years. So our theme this year is taming the big data beast. You may have seen our gorilla wandering the aisles.
I did.
But in all seriousness, all marketing promotions aside, big data includes not only analytics that's receiving a lot of attention with Hadoop and HDFS, but is also a lot about the core HPC requirements around research, simulation, discovery, everything from bioinformatics, genome sequencing, to even oil and gas, seismic, all of the traditional HPC workloads.
Sure. So why is it just such a beast? It's not just the size, is it? What other parameters make that big data so tough to wrangle?
Well, of course, scaling is very difficult. Making scaling easy is even more difficult. So you invest a lot of time and effort in a storage product to be able to start small and scale all the way up to hundreds of gigabytes per second. We had actually a really good example of that. This being international supercomputing, it's actually probably apropos to talk about Rutherford Appleton Labs, and they actually have the world's largest deployment of Panasas, and that was deployed just this past March, just a couple months back.
Okay, so what are they doing with that? What is their application?
So their challenge was weather and climate modeling, although they have some other aspects of scientific research that they do as well, and they actually needed more than 8 petabytes of storage. Scattered across several different research institutions, but the largest install was 6.5 petabytes of storage in a single file system, 6.6 actually to be precise. So that was over 100 shelves of Panasas storage, 10 racks, and that's capable of delivering up to 150 gigabytes per second of throughput. So when you have large Linux clusters that need the performance, you can obtain that by scaling up.
So Jeff, we hear a lot about big data. It's kind of the buzz right now, but when you talk to customers about big data, what do you mean?
So with big data, it's really about creating business value out of the data. So it's not a type of data per se, it's what you do with the data that you have.
Okay.
Right, so if you're an oil and gas customer and you have seismic data, the data is worthless until you analyze it. It's the process of extracting, how to more efficiently drill or get more resource out of a given reservoir. That's where the value is. And so the ability to accelerate the access both at a compute and storage side means potentially millions or tens of millions of dollars to them. Same thing for a cancer researcher trying to do genome sequencing. The same thing for weather simulation, trying to predict what's going to happen with the climate. All of those have a tangible benefit associated with those workloads. So that's how we define big data. Not only analytics, but also discovery and simulation and even what we call deposits, the storing of a lot of the large data.